The Great Lakes, situated along the US-Canada border, are the largest group of freshwater lakes on the planet, holding roughly 21% of the world's supply of fresh water. According to the World Health Organization, about 80% of the diseases in the world are due to poor quality of drinking water. Considering that, definite attention needs to be paid to every and all water quality issue that arises, especially issues caused by mankind. Fluorides are a well-known group of chemicals with a range of uses and effects, some harmful and beneficial to both humans and the environment. Added to our drinking water and praised for aiding in dental hygiene here in North America, their use is outlawed in most European countries. The growing controversy over use of fluorides has recently become more prevalent in the media. Studies have been conducted since the 50s concerning water fluoridation and public health. However, the effects of fluorides in the environment have been more or less ignored. In the next few minutes, we hope to shed some light on the ecological impacts of fluoride added to our environment and the effects on freshwater ecosystems.
Fluorides can be found in abundance in nature, in rocks, soil, in salt, and fresh water. But most of them introduced to the environment are introduced by humans.
According to the World Health Organization, along with various dental associations, fluorides have been proven to help prevent dental caries or cavities when used in small concentrations. However, exposure to higher concentrations of fluoride can lead to dental and skeletal fluorosis, as shown here. It starts out as a slight whitening of the teeth and ranges to stained brown and yellow and pitted teeth. In extreme cases, it can result in severe skeletal problems. According to a paper on groundwater quality published in the Hydrological Sciences Journal in 2010, about 62 million people in India are affected with dental, skeletal, and/or non-skeletal fluorosis from high levels of fluoride in their groundwater. More than 23 countries worldwide have problems concerning naturally occurring fluoride in their drinking water. However, at one point in time or another, fluoride has been added to the drinking water supply of almost all industrialized nations.
In 1945, Brantford, Ontario became the first Canadian city to introduce fluoridating water to public drinking supplies. In 2007, roughly 45% of Canadian communities had access to fluoridated water. In some communities, natural levels of fluorides present in the drinking water supply already meet the standards for healthy teeth. Here in Canada, along with many countries in the world, naturally occurring levels are well below the recommended levels. Increased public awareness concerning fluoride or other chemicals being added to our drinking water supply have sparked recent concerns surrounding the state of our drinking water. This has led to outlandish claims of fertility control and other conspiracy theories. This is exactly the opposite reason for fluoride being added in the first place. This is another example of the prevalence of information explaining the connection between fluoride and human health and a lack of information on how it affects the environment.
Opinions surrounding public water fluoridation range from claims of government mind control to the United States Center for Disease Control going so far as to call public water fluoridation environmentally friendly, as the chemicals added to drinking water are co-products of phosphate fertilizers and therefore their usage is reducing the amount of wasted natural resources. These controversies have, at least in part, been instigated by the outlawing of public water fluoridation in many European countries. That leaves North American water drinkers questioning why their government is not doing the same. From an environmental standpoint, the low levels of naturally occurring fluoride, paired with the partial removal of fluoride through wastewater treatment, results in an undetectable overall increase in concentrations, therefore making this perceived source of fluoride contamination from drinking water negligible.
Naturally occurring fluoride is present in the environment in different places globally, depending on the geology. Areas where the subsurface geology are granite or sedimentary rock, or areas prone to volcanic activity, have higher naturally occurring levels of fluoride in their water supply. Anthropogenic sources of fluorides include steel and aluminum smelting, production of ceramics, production and application of phosphate fertilizers, as well as the addition to public drinking water supplies. Hydrofluorosilicic acid is the most common type of fluoride used in water treatment plants today. However, sodium fluoride may also be used, but is more expensive and more challenging to handle due to corrosivity. The optimal range for fluoride in drinking water suggested by Health Canada is 0.8 to 1.0 milligrams per liter. A case study on the effects of fluoride in aquatic environments done in Montreal in 1990 reported naturally occurring levels of fluoride in the St. Lawrence River to be 0.13 milligrams per liter. The samples were taken upstream from the city in the Lachine Rapids. Another study done concerning fluoride contamination of groundwater in Mongolia recorded fluoride concentrations higher than 1.5 milligrams per liter in 62% of wells used for the water supply, with the highest recorded value being 8.0 milligrams per liter. However, like most waterborne pollutants, the effects of fluorides on the environment vary in relation to the different physical and chemical properties of the water that they are present in. This includes things like temperature, alkalinity, water hardness, and the presence of chloride.
Fluoride has been shown to cause adverse health effects in plants when absorbed out of the air, inhibiting photosynthesis and chlorophyll production, even causing defoliation and death. As a water pollutant, high levels of fluoride can have negative effects on a number of organisms, including fish, amphibians, insects, snails, shellfish, and protozoa, as well as some aquatic plants. The trout species, especially rainbow trout, are particularly sensitive to high levels of fluoride, showing growth and behavioral changes, prolonged hatching time of the young, and decreased survival rates. Under conditions with negligible or low levels of water hardness, these negative effects to trout may occur at fluoride concentrations as low as 2.7 to 4.7 milligrams per liter.
As discussed in previous lab exercises, increasing groundwater hardness due to sedimentation, geological processes, and mainly the application of road salts has been an increasing problem across Ontario. The toxicological effects of high concentrations of fluoride on marine biology may be experiencing a sort of ecological buffer. So although the levels of fluoride in the natural environment in Ontario may be low, too low to cause ecological damage, if levels were to increase, the biological community may not experience hardship. These increased levels of fluoride concentrations may not be observed in aquatic organisms as biomonitors. We hope this presentation has clearly outlined the facts surrounding how and why fluoride are introduced to Canadian drinking water and the low levels of naturally occurring fluoride. We have demonstrated that although fluoride levels are low and well below the recommended levels, the same cannot be said for other countries around the world, namely India and the Middle East. Investigations into ecological buffers that may exist and help to minimize the full impact of fluoride here in Canada are yet to be investigated. Similar research must be done concerning the relationship between climate change and fluoride contamination. We also introduced the controversy surrounding the supposedly helpful little ion. The public debate surrounding water fluoridation is growing and has helped create a greater overall awareness for what's in our drinking water. This just goes to show how large of an impact we Canadians have on our natural environment. So for Chris and Justin, I'd like to say thank you for watching and cheers.
Welcome, oh welcome to our little play. It's our hope that you all learn something today. I am a tooth, so white and so strong. I am a toothbrush, my bristles are long. Together we work to keep the